Hello everybody and welcome back to the Love2D for Beginners series. In the last two episodes, we learned how to move a simple rectangle on the screen using delta time and how to load and draw your image onto your game window. And in this episode, we are going to combine those foundational topics and take things up a notch. Instead of just moving shapes on the screen, we'll load an actual character sprite and move it smoothly across the screen by, of course, using delta time. And not just move the character on the screen, we are going to make the character face left or right according to the keyboard input. And not only that, we're going to limit the character onto our visible game window so that it doesn't go off bounds. So by the end of this episode, your game will start feeling much more alive. And without further ado, let's get started. Okay, I have opened my Love2D folder, and inside that I have opened my main.lua file inside VS Code. Now let's start by creating a basic player setup. Instead of just a rectangle, we'll load an actual image as our sprite like we did in our previous episode. So okay, let me click here and then start with our local player, and inside this we'll be using a table. So I hope you know about tables. If you don't know what tables are, we do have an episode on Lua tables, which is a part of our Lua for Beginners series. So I hope you check that out. Link will be in the description. But besides that, after creating our player table, we'll create a speed variable and we'll give it the value of 200. And let's say it is meant to be pixels per second. Pixels per second. And after that, we'll create a function called love.load, since we want to load our character sprite onto a variable. So we'll create an image key. So even if you don't know about tables, it is just a data structure inside Lua with key and value pairs. So if I type out player.image, this image is basically a key inside this table which will store some value. So if I type out player.image, it will create that key inside this player table. Now we'll use love.graphics.newImage to load our character sprite onto this player.image key, and inside that we will be using our Mario, that is I've named this Mary dot png. So this is basically a PNG of our 8-bit Mario character. So this will be our PNG that we'll be using today. Now after that, we will create the X and Y position for our player. So we'll create an X key, and let's say our initial position will be 100, and that is 100 units from the left of the screen. And after that, our position value, Y position value, will be 100 as well. So it will be our position from our top. And after that, I'll create just another key, and this will be our boolean to describe if our player is facing right or not. Now we'll be using this variable or this boolean to flip our sprite further in the future. So for sprite flipping. After that, we're just about done with our love.load function. So we'll end our function, and then we will move on to moving our sprite using the arrow keys. So for that, we'll have to use the love.update function inside Love2D. So this is a function that will run in every frame of the game. So inside the parameters, we'll use dt, that is delta time, and inside love.load, we'll use love.keyboard.isDown, since movement is continuous and we have to make the character move while we are holding down our key. So we'll use if love.keyboard.isDown. Now if our right key, that is our right arrow key, is down, then our player.x value should be increased. So player.x plus, it should be increased by our speed factor, and which will then be multiplied by our dt variable. So this stands for delta time, and I'll explain with a full presentation on why dt is so important in a while. So I'll create all of the functions and logics for our left, right, up and down movements, and then I'll explain about what dt means. So after that, I'll create player, since if we press the right key, the player dot facing right value will be true. And after that, I'll just copy this function, if condition, and paste it 3 more times, since we want one for left, one for up, and one for down. So if our player, if we, the users, press the left arrow key, the X position of our player, so suppose the player is right here. If we press left, it should go left. So the distance from our left edge, that is our X value, should decrease. So that is why we have to decrease our X value by speed times delta time. And since when we press our left arrow key, the player should face left, so dot facing right should be false. It should not face right. And after that, if our key is down, then our not player.x, our player.y value should actually increase. Since if we press down, the distance from the top of our screen should increase. If we press down, it should keep on increasing and our character should move down. So that is why we are using the increase or sum value. And facing right, let's say in this condition, is nothing. So when we press our keyboard down or up, it does not matter where our player is facing, so it does not determine that. So we'll cancel this in here as well, and we'll put this y value as minus for our up arrow key. So minus speed times dt, and this will be up. And after all this, we'll end our function, that is, we'll end our love.update function. Now this is how our love.update function will work. And let me just demonstrate the functioning code or the game, and then I'll move on to the explanation of delta time. And okay, for our character to be actually drawn on the screen, we have to use love.draw. So inside love.draw, we'll use love.graphics.draw. Since we are going to draw our player image, we'll access player, the table, and inside that we'll access the image key. So image, player.image, we'll have to draw the player at player.x position and player.y position. Now after that, we are done with our love.draw function. So let me end it and save it. I have autosave turned on and execute it with this batch file. And if you're new to our series, this is the batch file containing the location of our love.exe folder, love.exe executable file. And if we run this, it will execute our current game. So this is our sprite, our character, our Mario character that is loaded onto the screen. If I press right, it will move right. If I press left, it will move to the left. If I press up, up, and down, down. Now you might notice that this is not flipping. Mario is not facing left or right when I press left or right, and we'll fix that just a bit later. But before that, let me explain how delta time works and why it is so important to move characters on our screen. Okay, imagine this. You're running a car in your game and you want that car to move at 100 meters per second. Now, if a computer is running a game at 30 frames per second and another computer is running a game at 120 frames per second, if we just move the car 5 pixels per frame, the cars on the higher FPS computer or the game running on a higher FPS would zoom around like lightning, whereas on the computer where the game is running at a relatively lower FPS, let's say 30 FPS, the car would crawl much slower. So it would go this much slower. And that is where delta time comes in. Delta time aims to fix at this problem. Delta time tells us exactly how much real world time has passed between the last frame. So you can call it as a distance or the time distance between two frames, and its value equals to 1 by the total number of frames. Now when we multiply the speed or add our speed inside our x value inside the love.update function, what will happen is, since love.update runs every frame, the speed value is added onto our x position value in every frame. So at a computer running a game at 120 fps, the speed value is added onto our x value a total of 120 times. So the x value will be increased by 24,000 times each second. Now this is still a lot, but this is not the point. The point is that in a device with a lower FPS, or let's say where a game is running at a lower FPS, the speed value will be added onto our x position value only 30 times. So our x position value will be increased relatively slower. Now we don't want the speed of game characters or any objects inside a game to depend upon the number of frames the game is running at. The speed of a car should be constant no matter the game is running at 120 fps or 30 fps. So delta time aims to fix this. Now if we multiply the speed value with delta time before adding on to our x value, what will happen is even if the game is running at 120 fps, it will balance out the number of frames or the speed that is being added onto our x value. So 120 and 120 will cancel out, since the value of delta time, as we discussed just before, is 1 by the total number of frames. 120 and 120 will cancel out, and the distance or the position of x value will be just increased by a constant of 200. Now why delta time is really helpful is even if the game was running at 30 fps, the value of delta time would be 1 by 30. So 30 and 30 would cancel out and we would still end up with a constant speed of 200. Now we can see that when we multiply our speed by our delta time value, the speed of an object or the increase in x position of an object does not depend upon the number of frames, and that is how it should be. The speed of a car or that of an object should not depend upon how many frames the game is running at. It should always be constant, and delta time enables us to do just that. So the speed of the car would go from 5 pixels per frame to 5 pixels per second. Now I hope that is clear, and I'll also demonstrate why we should use delta time in a practical example by using the code that we just developed. Okay, now inside our code, if we remove the delta time multiplication inside our right key handling and left arrow key handling, let's see what happens if we run the game. Now we can see that the character of Mario is zooming past because the speed of our Mario character is not just 200, it is being added, 200 is being added to our x position a total of 60 times if my game is running at 60 fps. So that is why we need to use delta time. Now if we do times delta time, now let's run the game again and see that the right position is working just fine, whereas the left position is zooming past. So that is why delta time is so necessary. Now okay, let's fix this, and since our character is not facing left and right, we'll achieve just that. Now we'll make our character flip horizontally when moving left or right, and this small detail makes the movement feel much more natural. First let's adjust our scaling, so 0, and let's make it a bit smaller, so 0.5 and 0.5. okay, now inside love.draw, let's add an if condition. So since we have made a player.facing right variable already, we'll add an if condition. So if player.facing right, then what we'll do is we'll just draw the player as it is, since our character is facing right on the default. And after that, we'll go down and define an else condition. Else we will flip the sprite horizontally when facing left. Now we'll achieve that by using our scale value. So right now I just scaled my character down to 50% its size. It works like this. If you don't know, or if you haven't watched our previous videos, this is the character image or the character that you want to draw on the screen. This is its x position, this is its y position, this is its rotation value, which we don't want to mess with right now, and this is its scale value. So this scales down the character to 50% of its original size. Now we'll use that scale to flip the character. So we'll do love.graphics draw player.image, and then to compensate for flipping, we'll add some value to our x position value. We'll add the character width. So since I've scaled down my character to 50% of its size, we'll add 50% of its width to our character. And I'll explain while we do that and while we demonstrate our program. So 0.5 times our player.image.get, I mean not dot, colon get width. and after that we'll insert our player.y value for our y position, and then 0. Now normally for flipping I would do -1 and then 1, but since we have scaled down our character, we have to do -0.5 to flip our character horizontally on the horizontal scale. This is our scaling. The minus is for flipping, and then 0.5. Now that is essentially it. Now let's run our game and see how it runs. So right and left. See, Mario is turning left and right. Now why we added some value to our X position is because if we didn't do this, let's see what would happen. Oh, I didn't mean to close that, but okay. Now let's see what would happen. When we flip it, Mario would go all the way over here. Since it would flip starting from this starting position of Mario. So if we flip here, it would seem that Mario traveled a great distance when we flip left. So since we don't want it flipping inconsistently or like this, we add for that, or we compensate that by shifting our sprite by a factor of its width. So it'll look like it just stays in place and it flips. So when we do player.x plus player, let's say 0.5 times player.image and colon get width, if we close this and run, then it will seem like it just flips in place since we compensate for the flipping. So left, right, left, right. So that is how it works. So right now the player can walk right off the screen if he or she wants, and we don't want that. So let's fix that by clamping the player's position so that they can't go outside the game window. Now we'll do that by working with our love.update function. Okay, right now the player can walk right off the screen, so let's fix that by clamping the player's position so that they can't go outside the window. Now we'll do that by using love.update, and inside love.update, after this line, if love.keyboard is down right, then we'll use player x equals to, we'll use the math dot min method. So min player dot x plus speed, I'm going to type x plus speed times dt, and next our minimum value will be love.graphics dot get width minus player, actually 0.5 times since we have scaled everything down, 0.5 times player dot image and then get width. And we'll do the same inside all of the others. Now inside player dot is down, I mean love dot keyboard dot is down left, we'll use math dot max. So math dot max, and inside math dot max we'll use player dot x minus speed times dt and then 0. Now we'll do the same with our is down and is up. So I'll cut to that. Now as you can see, I have applied the same logic math.min and math.max to our is down and is down up as well. So after that, let's run our code and let's see what happens. So you can see that our character is limited on to our game window only. Now I'll explain the basic gist of this. Player.x.speed times delta time is where the player wants to go, but this value right here, our love.graphics.getWidth minus 0.5 player.image.getWidth, is basically our maximum x position allowed. Now you can do the calculation for yourself, but that is the basic gist of it. If our player speed or our player position increases than this maximum speed, math.min what math.min does is it selects the lower value. So let's suppose our maximum values is 830, and if the player player X position reaches 840, it will automatically clamp that value and pick 830 as our player position choice. So this will be essentially our maximum X position. And the same is with math.max player X minus speed dt and 0. If our player this is where the player wants to go, so if our left value goes on decreasing and reaches a minus value, it will pick the maximum value in place of these two. So it will always pick 0. This is the minimum position of our X coordinate, that is the left edge. And if our player goes below that, that is minus, it will automatically clamp that onto our 0 position. And the same is happening in down and up, but instead of width, it is getting player height and screen height. So that is how you clamp your character onto your screen. So that was it for today. We managed to learn how delta time keeps the movement smooth and consistent across all computers. We switched from rectangles to sprites. We made the sprite flip depending upon the direction that we moved, and we clamped the sprite to stay inside our game window. So inside our next episode, we'll take it further and talk about how we can create walk animations or walk cycles where we can make our character walk. So make sure you watch that video. If you like the video, hope you drop a like and subscribe to our channel for more such videos. And until the next time, bye bye.